Presenter today is Dr. Moyed Islam. Dr. Islam is a research faculty here at the University of South Florida's Center for Urban Transportation Research. His research interests include safety data, data analytics, and statistical modeling dealing with data linkage processes for various safety and related data resources. Moyed brings to Qatar the experience of working in the private sector on safety projects related to the implementation of the Highway Safety Manual in different states. He has been actively involved in predictive safety analysis of the Highway Safety Manual, as well as safety data analysis for the Strategic Highway Safety Plan, utilizing state-level crash, roadway inventory, census, vehicle registration, and endorsement data for different emphasis areas. He is actively involved in various TRB committees, including the Highway Safety Performance Committee, the Safety Data Analysis and Evaluation Committee, and the Moped and Motorcycle Safety Committee. He's published more than 15 research reports and peer-reviewed journal papers and presented over 25 presentations at several national and international conferences. And with that, I will hand things off to you, Dr. Islam. Take it away.
Everyone, hope you can hear me clear.
We can.
So the title of this presentation is Urban Roadway Facility Conversion with the Predictive Safety Assessment Tool, an application of the Highway Safety Manual. So I will discuss about the predictive methodology and the application of the predictive methodology from Highway Safety Manual in different roadway facilities and how to convert different facility type in terms of safety improvement or roadway improvements in the urban settings. So it will be more focusing on the off freeway system, meaning the arterial and other functional class of the roadways. So I want to acknowledge the scope of the work is supported by the grant from the Center for Transportation Equity, Decision and Dollars, funded by the USDOT under RITA and housed at the University of Texas at Arlington. And also I'm thankful to the Qatar team, Kong Chen, Amber Limay for their sincere and hard work and support, and Dr. Chan Yang Lee and Dr. Bartini for their feedback, support throughout the process. I'm also grateful to my mentor, Tim Newman, and co-worker Jigwang Zhao at the private sector, with whom I work closely with the Highway Safety Manual and different application in different projects in different part of the states. The learning objective of this presentation or of this study is to, within the scope of phase 1, is the ability to understand the predictive safety assessment of urban roadway facilities. As I mentioned, the different facilities and in the urban roadway settings, understand the conversion of roadway facility from one facility to another, and some level of understanding of the visualization and sensitivity of the safety result in terms of crash frequency and severity with the impact of traffic volume. And the disclaimer for this study and the presentation is the content of this analysis and the report reflect the views of the author, myself, and the Qatar team. And the crash prediction number are protected under the federal law, chapter 23 USC, section 409. The objective of this study is to enable the safety engineers, researchers, transportation planners at the agency level to understand and quantify the impact of safety. And this is very important since safety has been evolved from the qualitative to the quantitative domain. So in terms of that understanding, this is an important objective for this study. Also to develop a simplified framework in the MS Excel to evaluate the safety impact converting from different facility. Say for example, we are converting from 2-lane undivided to 2-lane undivided with 2-way left turn lane, 4-lane undivided to 4-lane divided road, two-lane undivided with two-way left turn lane to four-way undivided with two-way left turn lane, six-lane divided to eight-lane divided facilities. And there are other facility configuration that we'll see here. And then to have an understanding of the impact with the set of improvement, considering the different geometric configuration to the existing at the quantitative scale in terms of sensitivity analysis. So the highway safety manual as part of the evolution of safety science in this community and practice is coming when the state defines and recognizes the safe performance snapshot in the state of Florida with these statistics. As if you may not see very clearly, I can just indicate some of those. With the growing population and economy, Florida is growing with multiple direction, and the vehicle mile travel has increased from 207 billion with the 8% increase since 2011. That resulted in some of the safety consequences with the fatalities 3,176 that indicates 31% increase since 2011. With that, there are a lot of investment at the transportation planning level and with the infrastructure in terms of the safe and efficient movement of people and goods. So at this point, we are shifting from the nominal safety, where the safety was qualitatively attached to the compliance with the standards, warrants, guidelines, and the sanction design procedure, to the substantive safety, where the safety is defined in terms of frequency and the severity in any particular roadway section. And the highway safety manual is one of the major milestones where we document the process and practice, and the methodology is well established over the years, and also those methodology and the practice is getting embraced in the project development process, and it is being implemented in different part of the country. Different states are very aggressive and very progressive in terms of accepting highway safety manual in their project application. So highway safety manual integration in the safety manual, as you know, many of you know that there are 4 steps in the system planning level that identifies the needs and the program the projects to identify the site where the safety improvement will bring the highest benefit, identify the target crash pattern, and prioritize some of the expenditure in terms of improvements. So this safety planning is more of the application of part B. And the second one, project planning and preliminary engineering. Here at this phase, it tries to identify the alternative and choose the preferred solution, and also try to attach that with the target crash pattern, evaluate the effectiveness of the countermeasures, and compare the frequency of crashes between the alternatives. So it is still the application of part B. In the third stage, design and construction, here we apply the part C methodology, predictive methodology, where we evaluate the performance measure impacted by the design changes and assess the potential changes in the frequency by design exception evaluation. And the fourth stage, it identifies the operation and maintenance in terms of modification of existing condition to maintain and improve safe and efficient operation. So it is again a combination of application of part B and C. So in terms of highway safety manual application, there are multiple software and the platform for the predictive safety assessment. As many of you are familiar with the IHSTM, Safety Analyst, and CMF Clearinghouse, part of the predictive safety process and the application repository. Highway safety implementation by states. Here we see some of the states that has been accepting a highway safety manual support from the FHWA and also the pool fund states, as there are 13 here identified by the uh, green block, as you see. But there are more states are accepting the highway safety manual and implementing those in different phases of their projects, and there are more progressive mindset of this highway safety manual application. The supporting data for predictive safety assessment tool, I simplified it to the PSAT. There are multiple data that correspond to the operational and the geometry. As from the segment aspect, we look at particular type of facility, for example 2U representing the two-lane undivided, 3T representing the two-lane undivided with two-way left turn lane, 4U representing the four-lane undivided, 4D is four-lane divided, 5T is four-lane undivided with two-way left turn lane. Then we collect the segment length, traffic volume in terms of vehicle per day, on-street parking presence, average median width, street light parking, presence, speed limit, number of driveways, distance of fixed object, and density of the fixed roadside objects. In terms of intersection facility, we also look at three-leg stop control, four-leg stop control, three-leg signalized, and four-leg signalized. The traffic volume of the major and minor road that intersect at the intersection, the number of approaches with the left turn lanes, number of approaches with the right turn lanes, number of approaches with the left turn signal phasing, type, maximum number of lane crossed by pedestrian, and number of bus stops, schools, liquor stores within 1,000 feet of the intersection. So these are the important parameters, and we try to collect this data as accurately as possible through the design drawing or the Google Earth street view and the map plan view section. So the methodology or the working step for the PSAT tool is laid out in this format. Applying the SPF, safety performance function, by types of collision, multi-vehicle, single vehicle, vehicle pedestrian, and vehicle bicycle for the segment and intersection. So it is the HSM predictive methods for different facility. So the form of this SPF varies by the facility type. The CMF that represent the local geometric elements. So it is also based on the HSM predicted methodologies suggested elements. The calibration factors representing the local condition. So here we applied for the Florida roadway facilities. Considering the local condition, most of our evaluation, as I will show it in the next few slides, within the Tampa area. So the calibration factor is Florida recommended factors that is specified in the FDOT documents. Then we have the existing facility and the proposed facility. Existing facility is the base condition where we are trying to improve the facility with some widening or some other improvement in the facility, and that will be our proposed facility or the target facility. So for example, base condition is two-lane undivided. We are proposing it to two-lane undivided with two-way left turn lane. So it is 3T. The conversion factor is defined as in terms of numerator as the predicted crashes of the proposed facility. In the denominator, we have the predicted crashes of the existing facility. So it is a ratio of the conversion from 2U to 3T in this example. And finally, we have the crash severity distribution by crash type in terms of the safety assessment and the distribution, based on the distribution, and the impact of traffic in the crash frequency as part of the sensitivity analysis. The next figure here, it is showing how we are incorporating those working step in terms of data. So as I mentioned, the SPF are divided into different uh, different different types of crashes: multi-vehicle crash on the non-driveway, single vehicle crash on the driveway, non-driveways, multi-vehicle crash on the driveways. And then CMF application is based on the facility type. If it is 4-lane or below, then we have the left elements on the left side of this figure: on street parking, roadside fixed object, median width, lighting, automated speed enforcement. For the 6-lane and above, we have these are the geometric elements on the right side in the figure, as you see, are applied as the CMF for the 6-lane facilities. Then we apply the calibration factor for different facilities from Florida, and then the output will be the prediction of annual crashes by year and by mile. So I will show you how we are considering a 1 mile segment of the length, and we are considering the predicted annual crash frequency by that length of the segment. Then the distribution of crashes by type and the severity, and finally the sensitivity of crashes in response to the traffic volume. So the basic formulation of the predicted crash frequency by facility type is shown here. In the study area, as I mentioned, it is in Florida. In urban facility, we are focusing on the surface street, arterial mostly. We are looking at the segment level and intersection level based on the predictive method of chapter 12 of Highway Safety Manual of the first edition for 4-lane and below, and second edition, which is kind of under review for the next edition of Highway Safety Manual, and which is also part of the 1758 NCHRP 1758. And the safety prediction model, as many of you are familiar with the relationship with the safety performance function, crash modification factor, and the calibration factor. These are the roadway improvement projects and that are considered for this study. So we have considered 15 improvement considered scenarios, and most of those are related to the roadway widening, and few of them, three of those improvements are related to the intersection improvements. And as you see, the base condition to the improved condition, we consider the widening or some level of geometric improvement that will indicate the conversion from base condition to the proposed condition in terms of predicted crash frequency. This is the application site for this PSAT tool uh, in different part of Tampa area, and we are considering 1 mile of segment length with the start and end. And the base condition, as you see, 2U will be converted to 3T, 2U then converted will be converted to 4U, 2U converted to 4D. This is how your existing facility will be converted to the proposed facility within a particular segment length of the projects. These are the location in Google Earth, just to show you the geographical aspect of that different parts in Tampa area, just to see how the PSAT tool work with the safety performance of this location and their frequency and severity. And selection of these areas are totally random, and some of these locations are based on the traffic volume and their risk associated with the traveling along that corridor. The predictive safety assessment tool, in terms of navigation, we have the front page that talks about the overview, the purpose of the tool, user guidance in terms of where to input the input values, where to see the values, and output values and the HSM recommended values. And in the Excel worksheet, I will show you how the input and output works. The dashboard will consider the output of the two facilities and their conversion, and the sensitivity will show the response of the crash frequency and the time based on the traffic volume changes. Here the safety assessment tool with the dashboard, where we see the conversion factor in the main dial. As you see, it is kind of shaded to represent how much it is getting uh, represented by the crash prediction. So 0.81 meaning there will be 19% reduction when we convert 2U facility to 3T. And the frequencies and the type of crashes are represented here with the color coded for multi-vehicle collision and single vehicle collision. As you see, the color coding are presented here. So it is easier for the user or analyst to see the output of crashes and in terms of their conversion from one facility to the other facility, considering similar input or a bit different, considering the different consideration of the proposed facility in future. This is the sensitivity part of the two facilities, two-lane undivided to two-lane undivided with two-way left-turn lane. The blue line representing the two-lane undivided road with the total crash, and the red line represents the uh, total crash for the 3T, that means two-way undivided with two-way left turn lanes. And there is a sliding bar for the traffic volume for both facilities, so the user has the option to change the traffic volume to see how it works in terms of the changes in terms of total crash frequency for two different facilities. So here I will switch to the Excel. Can you see clearly the Excel, Christine?
Yes, we can see it.
Okay. So here the tab for 2U to 3T input parameters for two facilities. So here the blue shaded cells are the input for the user or the analyst. The green shaded cells are the HSM recommended values, the coefficient and other recommended values. There are some drop down, as you see here, considering different types of uh, driveways, and you can also change the number of driveways along that particular roadway segment. So for example, you want to change to the 32,000 vehicle per day, you can see those changes happening, and you want to keep the same level of input for both facilities just to compare on the same set of comparison scale. And you can change any facility, any driveway types based on your local condition, as you see here. And you can see the total crashes per mile per year is represented by the left side is the 2U and the right side is the 3T, the proposed facility. And if you go down, there are the CMF input. You, based on your geometry, you input the geometric elements on your target facility on the right side and the base facility, base condition. And finally, the speed limit input. If the speed limit is more than 30 or less than 30, based on that changes, you input that changes, and the changes will be reflected in terms of the HSM recommended factors. And at the end, you see the total crash frequency here for 2U and the 3T here. And the conversion factor is 0.75. Here you see that. This is the distribution of the crashes by type, and for 3T this is that distribution. Now if you look at the dashboard, this is how it looks like in terms of that conversion factor is 0.75. That means if we convert 2U to 3T under the same set of configuration, geometric configuration, we are expecting 25% reduction of total crash in 3T configuration. And this is the distribution of multi-vehicle collision between 2U and 3T, and single vehicle collision between 2U and 3T. And the last part is the sensitivity analysis, where I mentioned to you there will be multiple option of multiple crash types. So multi-vehicle only, multi-vehicle driveway, single vehicle only, vehicle pedestrian, and vehicle bike. So if you check off those conditions, you will see only the total crash frequency. And based on this sliding bar, you can change the frequency, change the traffic volume level, and you will see the changes happening with the total crash prediction for both of these facility. So one of the important interesting thing with this interesting understanding level with this sensitivity analysis is the crossover, where the two lines will cross each other. That means at their safety performance are very similar under different set of geometric different value of traffic volume. So it is an interesting implication for the safety engineer and the transportation planner. So can I go back to the main presentation, please? So this is the safety performance of the selected facilities in the study area, as I mentioned, in the Tampa area. So the first two rows representing the existing and the proposed. So 2U converted to 3T within that limit of the segment. The fatal and injury crash, KABC crash, property damage crash, and the total crash. So this is their response and the safety performance under the traffic volume and same geometric configuration. And the traffic volume data is collected from the Florida online traffic volume data, and the geometric configuration is collected from the Google Earth, as I mentioned earlier. So you see that there is a different response in terms of safety for both facilities. And this is how we calculated all of this facility conversion based on the PSAT tool. There are some facilities that were not found in the Tampa area. Maybe it is not in the urban area, maybe it is more in suburban to rural areas. So those are in the theoretical value. So we set a reasonable values for both of the facility in terms of their traffic volume and reasonable geometric configuration. So that's why they are noted as theoretical. So with the same table, we have the conversion factor. So this is the ratio of proposed facilities total crash predicted crash divided by the existing total crash frequency. So as you see, the numbers are sometimes below 1 and sometimes above 1, and sometimes it is quite high. For example, in this case 2.13 and 4.68 are quite high, even though we are closely checking what is the input parameters and the geometric configuration. So that implies some of the coefficient or the SPF parameter that is very much reflection of their particular operation characteristics of those facilities. For example, here we have 4SG, 4-leg signalized control, signal control to 4ST. So when we convert from 4ST to 4SG, there is a huge increase in the crashes, and that is the nature of the 4-leg signalized intersection because of the traffic volume and so many other factors, operational factors that impact this coefficient in the SPF, and that's how it is reflected with the higher values in the conversion factor. So this is just a display of the conversion factors with respect to the no change in the horizontal red line. So here we observe the different facility conversion has different implication in terms of its predicted crash compared to the base condition. For example, 2U to 4D, we are expecting much lower crashes in the 4D facilities. 4U to 4D, we are expecting quite different, quite low number of crashes in the proposed facilities. So here, this is just a graphical way to explain the conversion factors with respect to the baseline of no change. So there are some caveats associated with this tool. A development of calibration factors for 6 lane and above was not scoped in this phase of the study, and the FDOT documents and the research done earlier was reflecting the 4 lane and below. So we captured those calibration factor, but not for the 6 lane. And this is not scope for this study we have done here. So later on we can update the values, but at this point it is a default value of 1. One-way roadways are not included in the analysis. So some of the one-way road, especially in NCHRP 1758, showed the urban areas where we have many one-way roads. But in this analysis, we excluded them just to show the major roadway facility conversion. Two-way left turn lanes at the 6-lane roadway intersecting was not part of the improvement, because some of the two-way left turn lane or the left turn lane, because of the traffic volume and operational advantage they are provided there. So we have not included the two-way left turn lane conversion. 6 lane and above are still under review of HSM edition 2, which is with the research report from NCHRP 1758 is already published, and there are still some thing under review for some of the inclusion in Highway Safety Manual Part 2. Pedestrian and bike specific parameters for 6 lane and above was not well defined, but in future we'll look into particular geometric configuration where pedestrian and bike are important to consider. So I'm wrapping up. If you have any question, you can send through the question box as mentioned earlier. So very recently, if you are aware of the recent study released by American AAA Foundation for Traffic Safety with the American driving survey, that indicated that 11,500 miles every year is driven on the road. That is equivalent to 2 round trips from San Francisco to DC. And if you go through the report, you will see some of the research brief indicates that Americans on average spend 70 billion hours behind the wheels, and that clearly indicates the risk associated being on the road, right? So at this point, the study here is intended to provide some quantitative assessment of those risks, and applying this safety assessment tool, which is based on the Highway Safety Manual for Safety Professional Decision Maker at the planning phase of the roadway improvement. So before you improve the road or before you go for any improvement or widening of the road, at least you have an informed decision through this tool. You can know that this is the safety performance of my base existing facility and the proposed facility. The second two things are, the first thing is the conversion factor. As I mentioned, the decrease of the crashes are indicated by when the conversion factor is below 1, and if you take the difference from 1, you will get the percent decrease of the crash when we convert from the base condition to the target condition, target facilities. Similarly, for the crash increase is indicated when the conversion factor is more than 1 and you take the negative of that difference. And this is the percentage. If you remember the CMF definition, CMF is very close to this concept, but we are still calling it the conversion factor, just to be clarified with the traditional concept of CMF and CRF. And finally, the sensitivity analysis, as I mentioned, it is a sliding bar, so you can see the within the range of the traffic volume that is recommended in highway safety manual. You can change the traffic volume and see the responses in terms of crash frequency, severity, and types of crash. And another interesting part, as I was indicating here, that intersection of two lines, that is the crossover between the existing and proposed facility, indicates whether they will behave similarly, their safety performance will be very similar or different, how different that would be. And with that, I'm wrapping up my presentation. If you have question, comments, suggestion, you can ask me now.
All right, thank you very much. As Moyed said, if you have a question, just go ahead and type it into the Q&A box, and we will read those aloud. We had one question come in here. It says, after this phase of the study, what would be your focus for the next phase? Do you have anything in mind?
Yeah, that's a good question since we are done with the phase 1. So in phase 2, there are some caveat I mentioned in this phase. So we'll try to address those as much as possible. And we are also thinking to include the cost benefit component to that tool. So at least we can get a sense of cost benefit metrics of the proposed facility and the target facility. So I hope that clarifies some of the curiosity.
All right, thank you. We have another question that came in. It says, when you talk about prediction, what data or variables should you consider?
Yeah, this is another important things for the SPF development. So highway safety manual already established the procedure that these are the parameter we should consider, and those are specific to the geometry and the operational characteristics. For example, the traffic volume, then on-street parking, speed limit. Those are some of the important parameters that are exogenous in nature, that are not endogenous. People who are listening to this presentation or working with the safety models, they are familiar with these terminologies when they develop the model. So in this SPF development or the application of SPF in a highway safety manual, they are totally exogenous. So they are capturing more of these prediction more accurately than other factors. But having said that, there are some caveats with these models, as we have discussed in the research community under Highway Safety Performance Committee many times, and we are expecting some new additional or supplemental analysis will be included in the Highway Safety Manual Part 2, which will be coming soon sometime. So these are the important things we should consider in the model development, and we should always make sure the variables are exogenous in their nature. Thank you.
Thank you. Next question here is, how much HSN application in the project level is getting accepted by the community?
Yeah, this is another important things. I think in Florida, agencies and the research communities are very engaged applying the highway safety manual. And I work with Illinois, Nebraska, Missouri. So those states are also accepting, even in 3-4 years back, they are very much interested to apply predicted crash frequency to see how they behave when they're developing new projects. And so it is important, and people are accepting these days. And with the new highway safety manual publication that is coming up soon, people will be more accepting those prediction process and the application aspect of that. So hope that answers your question.
All right, thank you very much. I don't see any other questions coming in, but for those of you on the line, if you do have any other questions, please feel free to go ahead and type them in the box or reach out to us and we'll get those to our presenter and he'll respond back to you via email. You will notice that a survey opened up on your screen. If you could take a moment and let us know how we did and just let us know your interest for the future, this helps us present information that you guys are wanting to hear. Please tune in on April 11th when we will present USF Bull Runner Operational Analysis and Strategic Plan with our three presenters that you can see there on the screen. Thank you very much for attending today's webcast. Thank you, Dr. Islam, and hope everyone has a great day.
Thank you.